Hey, Dr. B here, and let's take a look at chemical bonds. Since most of the elements are unstable in nature, it's not surprising that they bond to each other in many cases. The world around us is not mostly individual elements, but bonded elements. Let's define a chemical bond as that force, whatever it might be, that holds two atoms, or if we're being specific, ions together. That driving force, that line that forms and why it does. Which elements don't form chemical bonds? That's a great piece of evidence to understand chemical bonding, and the noble gases just don't. That last column on the periodic table, helium, neon, argon, etc., they don't form chemical bonds, and that's a great hint at explaining the ones that do. Why do elements form bonds? To obtain that noble gas configuration, that full outer shell of electrons that they lack, but by either sharing or transferring electrons, they gain it. So let's take a look at the different types. If the bond is look between these guys, well, I think those are the left of the staircase, the metals. We're talking about a metallic bond. For example, iron bonded to iron. If it's this side with this side, that means a metal to a nonmetal. We call that a ionic bond. This typically involves the transfer of electron. And there's lots of examples. I did table salt as an example. Finally, if you're just to the right of the staircase, you're looking at a situation where you would think they each want to gain electrons, and they do, but there's these nonmetals can obtain their noble gas configuration by sharing electrons. We call that covalent bonding. An example would be a carbon to chlorine bond. Both of those elements are in the green area. There is another type which we should be aware of if we're going to be complete here, and that is a covalent networked solid. We need to be able to explain such unique substances as diamond or graphite or glass. And this is a unique type of bond called a covalent network solid, kind of like a metal where it's a repeating network of those types of bonds, but not involving metals, but rather involving covalent elements. Right at the staircase. Okay, let's look at some added detail here. Let's consider the polarity of these covalent bonds. So we're only dealing with this region here, right of the staircase, the nonmetals. And let's consider what's going on. This carbon-carbon bond, we know it's covalent, but can we say anything else about it? We can say it's nonpolar covalent, meaning that bond is not polarized. That should make sense since this molecule involves two identical nonmetals, carbon to carbon. There's no reason to consider that, there's no reason to believe that they would have an unequal sharing of electrons, being identical, right? Each has the same electronegativity. If we have a carbon to oxygen bond, well, that's a different story. Oxygen is way over here and would desire electrons much more than carbon would. That would be polarized, with the electrons being a little bit more here. You can write slightly negative here, slightly positive there. Therefore, if it's different nonmetals, they are polar covalent, with one exception, the carbon to hydrogen bond being present in oils and fats and all sorts of nonpolar substances. Since the difference in electronegativity is only slight, we consider that to be a nonpolar covalent bond. So that's the in-betweeners, right? Between, if it's covalent, you can get a little bit closer to ionic or not close at all to ionic. If it's polarized, it's getting more unequal sharing of electrons, a little bit ionic. Okay, let's do a little quick quiz here. Tell me what type of bond we're dealing with. Well, metal to nonmetal, I think that's ionic. Two identical nonmetals, nonpolar covalent. Non-identical nonmetals, polar covalent. Identical bonds either case, so we can deal with either one. It's a nonmetal to a metal, ionic. They're double, but don't let that worry you. It is a nonmetal, but they're different. So that is a polar covalent bond. Later on, don't lead that to make you believe that that is a polar molecule. Notice it's symmetrical. That's a different story. But it is polar covalent bonds. Metal to nonmetal, ionic. Metal to metal, metallic. Carbon to carbon, I'd say nonpolar covalent, but if you tell me it's graphite and it goes on forever, that's a new specific type of bond. We'll call that a network covalent solid. This is an introduction to chemical bonds.